video will cover section 2.3, part 2. So last class we left on problem number 6. So we're going to start from there. And we have here negative x to the 4th power plus 4x cubed minus 4x squared. So the last thing we did last class, we were factoring it to find the zeros, right? And so we found, first of all, we factor a negative sign out, and we got positive x to the 4th minus 4x to the 3rd, and then plus 4x squared. After that, I believe we factor an x squared, right? Is that what we did? So negative x squared, and if we do that, we will get x squared minus 4x plus 4. Now, after that, we factor the trinomial square into the product of two binomials. And so that was x minus 2 and x minus 2. Oh, yes, negative x squared. Thank you. So I'm just going to rewrite this here. So negative x squared. And then what I'm going to do is combine these two factors. So since they are the same factor, we could also write it as x minus 2 raised to the 2nd power, the whole thing. And so what we're going to say here, if we were trying to find the zeros, you already know that you take each factor and you equal it to 0, and then you solve for x. So the first thing we did here was multiply the whole thing by negative 1. Negative 1 times negative x squared is positive x squared, and then 0 times negative 1 is 0. And here to undo a square, we take the square root. So we do that to both sides, and we get that x is equal to 0, because the square root of 0 is 0. Now, if we look at the other factor, is x minus 2 squared is equal to 0. So we take the square root first, and that will cancel the square because they're inverse operations. So we get x minus 2 is equal to 0. And from here, we know that we need to add 2 or move the 2 to the right side. That will make it positive 2. Okay, so we only have 2 zeros, but we know that the degree of this polynomial is 4, right? So we could have at most 4 zeros. Now, what I want you guys to look at is at the degree of the factors that we have here. So this factor has an exponent of 2, and this one has also an exponent of 2. So what I want you to write next is a little definition, and then we will talk about why the graph looks that way. So for the polynomial function f, if the same factor, let's call it x minus r being a constant, just a number, if that factor occurs k times, k is just stands for a number, k times we call r a zero with multiplicity k. So what we're going to say, using the same example, that the multiplicity of this factor is 2, right? And so 2 because we have the factor raised to the 2nd power. Gabriel. So would you say that 2 is an odd or an even number? Even. So what we're going to say here is that if the multiplicity is 2, that has the factor will be of even multiplicity. And so multiplicity is important because that will tell you what happens to the graph around the x-axis. So we have zeros with even multiplicity. Those will be zeros where the factors are given, if the factors are raised to the power 2, to the power 4, to the power 6, to the power 8, and so on. Now, if we have even multiplicity, we will also have odd multiplicity. And so those are factors that occur once So because 1 is an odd number. Also, if the factor occurs 3 times, 5 times, 7 times, and so on. So what happens here is that when we have even multiplicity, the graph is going to, well, here's our 0, and they are real numbers, so that you can see them as x-intercepts. So what happens is that the graph is going to touch the x-axis and turn around. Some books refer to it as it bounces back. Okay, our book says it touches and it turns around. So let's go look at the next slide. Okay, so multiplicity. So like I told you already, we have even multiplicity. So if R is a 0 of even multiplicity, that means that it comes from a factor that occurs twice or 4 times or so on. So what happens is that it will touch the x-axis and turn around at that particular number. Okay, the other case is when R is a 0 of odd multiplicity. And so what happens there is that the graph will cross the x-axis at that particular number, at that, whatever your number is for your 0. So 2 cases. Now there's one more thing here, that the greater the power or the exponent of your factor, if multiplicity if the multiplicity is greater than 1, the graph is going to, it tends to flatten out near those zeros. Okay, so I'm going to solve example 7, and then I'm going to ask you that you do the checkpoint 7 on your own. Okay, so we have here 2 different factors. In fact, we have 3 factors, because if we consider 1/2, that is also a factor, right? However, for the purpose of finding zeros, we're not going to take that one into account because we cannot do the following. 1/2 is equal to 0, right? That would be nonsense. So we're not going to use it for the purpose of finding zeros. So in this case, well, I'm only going to use the other 2. So my first factor is x plus 1. And so if I want to find the zeros, or zeros that comes from it, you guys know it will be x is equal to -1, correct? Yes? If we equal this to 0, and then we solve for x, it will be x is equal to -1. Now, how many times do we have that factor occurring on the function? We don't see a number, so we assume it is a 1. So, will 1 be odd or even multiplicity? Odd multiplicity. So then for the behavior, around the x-axis, you can look at your notes. Is it going to cross or turn and touch around? It's going to cross. So it's going to cross the x-axis at x is equal to -1.
Wait, what do you mean by cross? Oh, no.
Something like this. So -1 is here. So the graph, let me see. That what would be the degree of that polynomial, guys? 2?
No.
Oh, I hear a lot of numbers. Okay, so if we were to expand this factor here, we will get what?
Oh, you need come
What will be 2x times 2x? 4x squared. Okay. And so if we multiply 4x squared times x, what will we get? 4x cubed, right? So the degree of this polynomial is 3. Now, just for fun, let's see if we could remember how to find a sub n. So a sub n is the leading coefficient. Remember the leader of the line? So if we multiply 4x cubed times 1/2, what do we get? 2. Yes. Isn't it multiplying by 1/2 the same as dividing by 2? Yes. Right? So 4 multiplied by 1/2 will be 2. So that tells me that the leading coefficient is positive 2. So according to the behavior of the graph, it's going to look like something like that, like a linear function. So if I was to graph this one for you, well, let's find the other 0 first. Yes.
If it was -2, it would be like the other way around. Right?
Correct.
There.
Yeah. So that would be like a positive linear function, leaning to the right. Okay, so let's look at the other factor, and then I'll show you a very rough sketch of the graph. So the other factor will be 2x minus 3 squared, and that is equal to 0. So I'm going to solve this one on the board, just to make sure you can write it on the side of your paper. So if we have 2x minus 3 squared, and that equals to 0, the first thing we do here is take the square root on both sides. That will take care of the square because they are inverse operations. So we have 2x minus 3. The square root of 0 is 0. Now we have 2x, and the -3 is subtracting to the x, so I'm going to move that across, and if I do that, it's going to turn to the inverse operation, which is addition. In other words, it will be positive 3 on the right side. Now from here, the 2 is multiplying to the x, so what I need to do is divide by 2. So that will be 3 divided by 2. So the 0 that we obtained from here is x is equal to 3/2. Now if we look at the factor, how many times does that factor occur on the function? 2. 2, right? So is that odd or even? Even. So we say it is of even multiplicity. And so if you look at your notes, their behavior should be that it's going to touch and turn around. And we're talking about the x-axis here. It's going to touch the x-axis and turn around at x is equal to positive 3/2. So just a little rough sketch of this graph based on the, yeah.
How do you know if it's going to touch?
Well, because I already know. But if you don't know, you can check your notes. So if it is of even multiplicity, it will always touch and turn around. And if it is of odd multiplicity, then it's going to cross the x-axis. So when I give you guys the study guide that I was telling some of your parents yesterday, you're going to have to actually go back to your notes and rewrite a lot of the statements or the theorems that we have. Some of them will be like filling in the blank.
Rewrite it as a
Like that, as of that, yes, because this is a dual credit class. Okay, so again, rough sketch of the graph. Well, I need to see where we're talking about. So we already decided that it is of degree 3, the behavior is going to be like that, the end behavior. The other 0 happened here at 2/3. So this is 1 and this is 2.
3/2.
Oh, 3/2, I'm sorry. So that will be somewhere here. And the other one is here. So then what happens is that we already established that at -1 is going to cross, correct? Okay. And then somewhere it's going to maybe turn, well it has to, and then it's going to touch the x-axis here, and then it's going to bounce back. Yes?
How do you know where it turns?
When it turns?
Like,
No,
if
where
a
it
little
turns.
plane.
Where it, oh, okay, that's a very good question. So one thing we could do is find, and that's what we're going to do on the last 2 problems that you guys are going to do on your own. One thing you could do is find the y-intercept. So you guys already know that to find the y-intercept, what you need to do is substitute x with a 0, correct? So if I'm going to do that, or we find f of 0. So if I do that, it will be 1/2 times 0 plus 1, and then 2 times 0 minus 3, and then we're squaring all of that. So in this case, first we do what's inside the parentheses, so it will be 1/2. 0 plus 1 is just 1. 2 times 0 is 0. 0 minus 3 is -3. Now we're going to do what's inside the exponents. So that will be 1/2 times 1 times 9. So in this case, we will have 9/2. So what this tells me is that the y-intercept should be somewhere 1, 2, 3, 4, 5. So 9/2 is 4.5, correct? Yes? Okay. So I'm going to erase this one. But like I said, it was a rough sketch. So somewhere here. Now, it doesn't mean that it's going to necessarily turn on the y-axis, but what you could do is use your table of values and get a point that maybe it is between the y-axis and the other 0.
What if we don't have the calculator and it's neither on the y-axis? How do we find it?
Well, you will need calculus for that.
Okay.
And so, Robert, let's see if you know this. When you have those critical points, right? Turning points, in calculus we call them critical points. What is the slope of the tangent line at those turning points? 0, right? So let's pretend that is going like this, and then it turns here, and then it bounces back, and then it goes like that, okay? So the concept of the derivative, what I was asking Robert, was the slope of the tangent line. So at those critical points, remember how I always tell you it's not increasing or decreasing? It's simply just turning, it's changing. So when you take calculus, you take the derivative of a function, and then after that you equal the derivative to 0, and that's what gives you those turning points. And we say the slope is equal to 0 because it is just a horizontal line. Okay, so we couldn't find those for sure without calculus, but for now what I will recommend is that you look at your table, or for example you could find f of 1 and see like more or less where it falls. Now on the exam I'm not going to grade you on those turning points. What I'm going to be looking for is that you have the correct x-intercepts, perhaps the y-intercept, and of course that you know the difference if it crosses and if it touches and turns around. But I'm not very picky about those turning points because without calculus you can't really find it.
Wouldn't you have to use the first derivative test to find if it's
0?
yeah.
How do you do that? Like,
I'm not going to teach you that because this is pre-calc. Yes. No. Is there an emergency? Because we're going to take a break. Could you hold it? Just go down. Okay, so, wow, you guys are asking good questions. Good question. Okay, so anyways, thank you, Biryani, for that question. So now what I want you guys to do, you don't need to do the rough sketch because you're going to do that on the last problems. I just want you to do the same thing that I did here for example 7, and I want you to find the factors, figure out if it's odd multiplicity, even multiplicity.
let's see.
And then you will describe the behavior, meaning that you will tell me if it crosses or if it touches and turns around. Okay? All right. So get working, guys. Come on. Yes. Read your notes. Okay, so for the factor x minus 5, if we take that factor and equal it to 0, we will get x is equal to 5. I know that it was raised to the 3rd power, but maybe I shouldn't skip that step. So if we take the cube root, of course that will cancel the 3rd power, that we will give x minus 5, and then we take the cube root of 0, and so that will be 0. Now from here, minus 5, move it across so that becomes positive 5. Now, we look at the exponent, and that is odd. So according to our notes, is going to cross the x-axis. Now, tell me your question again.
Well, since it was 1/2, do we multiply it with 2?
Mm-hmm. Yes.
And
So
then we make it negative 1?
something like that, yes. So we take the x plus 1 is equal to, I'm sorry, plus 1/2 equal to 0. And one thing we could do here is x will be equal to negative 1/2. Now, that factor, now that you mention it, will be similar to something like 2x plus 1. Let me show you why. So that's something that Andrea was referring to. So if we're solving for x here, it will be 2x is equal to negative 1, right? The positive 1 becomes negative 1. And then the 2 is multiplying, so then we divide. So do you guys see that from this factor or this factor, we get the same 0, right? This is going to become important in the following sections, all right? Just so you know. Okay, but so going back to this part, so we get that the 0 is equal to negative 1/2, and now we look at the multiplicity of the factor, and that is a 2. So will that be odd or even? X's? Even. So even multiplicity. And so is it going to touch and turn around or cross? Okay, so it's going to touch and turn around. Okay. And so that's it for that. Let's go to the next slide. We're going to take a break. After this one. All right, so the intermediate value theorem for polynomial functions. So I want Lorenzo to read it out loud, please.
The intermediate value theorem?
Yes.
Okay. Let f be a polynomial function with real coefficients if f of a and f of b have opposite signs. Then there is at least one value of c between a and b for which f of c equals 0. Equivalently, the equation f of x equals 0 has at least one real root between a and b.
Yeah. So do you guys understand that?
No.
No, right? But I'm going to teach you how to understand it by breaking it down, so that when you are in another class, you could read the book and be able to understand it. Is that a cell phone?
What? Oh, I'm not. I was reading.
Okay, put your cell phone in your back. That's not your back. Okay, so let's see. We're going to read it by parts. So f is a polynomial function. We understand that, right? Polynomial functions, they can have real coefficients. We already know that. So now we're going to have two x values that they're referring to here. And so, actually, let me do this. So we have an x value equals to a. And so let's plot that one here, a. Now, the corresponding y value to that x value is f of a. Attention, over here. So let's plot the point here, f of a. So would you guys say that f of a is positive or negative? Positive, okay. Now we have another x value, and that x value, we're calling that b. So that one is going to be here. So a and b are the x values, f of a and f of b are the y values. So now we need them to be of opposite signs, right? It says here, opposite signs. So if f of a is positive, what do we need to do with f of b? Negative. Negative, right? So I want you guys to extend the y-axis a little bit. Oops, that's not straight. Okay, so f of b, I want it to be, let's say here. Okay. So now, what the theorem is saying is that if f of a and f of b have opposite signs, we already established that, right? One is positive, one is negative. If that is the case, there is at least one value, and we're going to call that c, between a and b. Not necessarily the midpoint, it's just between it, okay? So I want to have it closer to b, for which f of c is equal to 0. So if f of c is equal to 0, that means that the y value that corresponds to c is 0, meaning it will be on the x-axis. X-axis. Okay? So that's what the intermediate value theorem says. That if you have two x values with opposite signs for their y values, then there must be a 0 in between those two x values, because the graph somehow needs to cross the x-axis. All right? That's how you go from a positive y value to a negative y value. Okay, and now equivalently, the equation f of x equals 0 has at least one real root. How do we know it's a real root and not an imaginary root? Imaginary, very good. Imaginary roots don't even touch or cross the x-axis. So if it is a real root, it is an x-intercept. Okay? All right. Wake up. You again? Okay. So now I'm going to answer this problem, and I'm going to tell you right now, this will definitely be on the test. And it's such an easy question to answer, but if you don't know the name of the theorem, then you're probably not going to know what to do with it. So the question of on the test will say something like, use the intermediate value theorem to determine if there is a 0 between 2 and 3. That's it. So what you need to do is the following. First, we have x is equal to 2 and x is equal to 3. Those are two x values. So what you need to find is f of 2 and f of 3. Now, I know you guys want to go on a break, so I'm going to have this side of the room find f of 2, and then you guys find f of 3, okay? You will do that by doing what? Okay, all right. So substitute for every x on the function. Come on, Chris. So you guys are finding f of 2. F of 2. And then you guys okay, so I go up here. And you know what this is? Is it an alphabet? Okay, so what do you guys get for f of 2? Okay, and then for f of 3, 6 positive. Correct? Yeah? All right. So now let me ask you a question. Are they do they have opposite signs? Yes. Yes. No talking. No talking. So because f of 2 and f of 3 have opposite signs, This is how you want to answer your question on the test. By the intermediate value theorem, there must be a zero, let's say a real zero, between x equals 2 and x equals 3.
Can we find out what the zeros?
Well, yes, we could, but for the purpose of this question, we don't have to. So on the test, to kind of like shorten your time answering a question, just that will be enough. Okay? All right. So now let's write our little statement, and then we'll go on a break.
So if they have the same signs,
Then there's no real zero between them. Mhm.
just write notes at the end.
Yeah.
But if they have the opposite signs, there is zero between?
Correct. Correct. Yes. All right. So now let's write the statement that goes there, and then we'll go on a break. So in general, and this is referring to turning points. In general, if f is a polynomial function of degree n, then the graph of f has at most n minus 1 turning points. All right, so let's see. Let's think about a quadratic function. And so let's just use f of x equals x squared. So what is the degree of a quadratic? 2. So what will be 2 minus 1? Correct. So turning points 1. Let's think about a cubic function. So the degree is 3, right? So how many turning points are we going to have? 2. 2 turning points.
One less than the degree?
Correct. 1 less than the degree. So, yeah, I like the way you said that. 1 less than the degree. Now, you guys need to see here where it says at most. That means that they're not going to have those turning points necessarily, but that's the maximum number of turning points they could have. They could have less. There are some polynomials of degree 4 that look like parabolas. They only have 1 turning point. So if we look at the example here, well, before we do that, let's think about a linear function. Is a linear function a polynomial?
You said yes.
Yes, it is. Because the degree has to be non-negative integer, right? So what is the degree of a linear function? 1. So let's say g of x is equal to x. So the degree is 1. So how many turning points do we have? 0. 0. Right? And isn't it true? It's just a straight line. Now let's look at the picture here. And let's count the turning points. So we have 1, 2, 3, and 4. So we have 4 turning points. So what do you guys think the degree could be? 5. Very good.
Is that what it is for sure?
Not for sure. It could be a higher degree with less turning points. Okay, so I'm going to pause the video. We're going to go on a break. And then when we come back, we'll finish the section. And then I'll go over your test.
Is there a way of finding out the degree?
Okay, the next slide, it has a summary of everything we did during this section, okay? And so on the test, you will definitely have a question where you will have to do something like this. And so let's go over it. First of all, we went over what a polynomial looks like. We established that a sub n is the leading coefficient, right? The leading coefficient, that would be a sub n. And then the degree of the polynomial is n, which is the highest exponent. Now, when it says here for number 1, use the leading coefficient test to determine the graph's end behavior. So remember, you have to establish if n is odd or even, and then you also need to establish if the leading coefficient is positive or negative, right? And that will tell you if it will be it will be something like rises from the left, falls to the right, or rises from the left, falls to the. Did I just say something?
Yeah.
Or for example, if we take something of even degree, then that will be either both going up or both going down. Correct? All right, but you do have a table to look into those. Now, number 2, it says here to find the x-intercepts by setting f of x equal to 0. In other words, making y equal to 0, and then you solve for x. Now, if you have a factor, if you have an x-intercept that is the result of a factor with a multiplicity greater than 1, or even for 1, we need to establish if that multiplicity is even. If k is even, remember those are numbers when you have factors that occur once, or 3 times, or 5 times, or 7 times, or so on. So when that happens, the graph is going to, oh my god, or this circle's wrong. Sorry. Maybe I'm not such a good teacher. So if k is even, those are numbers like 2, 4, 6, and so on, right? So if that happens, then the graph is going to touch the x-axis and turn around when the multiplicity is even. When the multiplicity is odd, then the graph, and those are when the factors will occur once, or 3 times, or 5 times, or 7 times, or so on. So when that happens, the graph will cross the x-axis. And also we went over briefly that if the multiplicity is greater than 1, the graph tends to flatten around that 0. Now, number 3, it says to use symmetry. I'm sorry, that will be number 4. But number 3 says find the y-intercept by computing f of 0. In other words, you let x equal 0, and then you find the y value. And we know at x equals 0 because if it is on the x-axis, it must be 0. X must be 0. Now here we use symmetry to draw the graph. Now, this comes from the fact which functions are symmetric with respect to the to the y-axis.
What do you mean?
So when you substitute x with a negative x and you get the exact same function, would you say that function is even or odd? Even. Something like that. Now when you substitute f of negative x and you get the opposite of the original function, those functions are odd. The specified function and function. I know we have a lot of odd, even. That's why it's very important that you do the review when I give that to you. Odd functions, they look like that, symmetric with respect to the origin. Also, it will be helpful if you determine the number of turning points. So remember that will be 1 less than the degree. So if the degree is n, the number of turning points will be n minus 1. Okay, so we are done with this section. What I'm going to ask you to do now is that you graph those functions, okay? And for this, you're going to get with a partner who is behind or in front of you. Not next to you, in front or behind. Quiet. Okay, so we graphed the polynomial, and we found the leading, by using the leading coefficient test, the degree is 4, the leading coefficient is 1, so we decided that the graph will be rising to the left, rising to the right. The x-intercepts, we found those by factoring, by making f of x equal to 0, factoring, and then we found these two factors, and if you notice, they're both of what type of multiplicity? Even multiplicity. So because of that, the behavior of the graph is going to be touching and turning around, right? So it's going to touch and turn around. The y-intercept, what do you guys find for that? Okay, so 0,1. Okay. So I'm going to just graph this one quickly, and we will go over the other one next class. However, the homework is still due, okay? It is due on Tuesday. Yes, due Tuesday. All right. So what I want to do now is I want to go over the test.
Are we still doing turn it on?